All right, everyone, we are now going to practice some angles of elevation and depression problems. A reminder, elevation is when we're looking up, so we will draw our right triangle looking like this. If the problem is depression, we are looking down and we'll draw our triangle like this. That just makes the problems so much easier, especially when we have to draw the triangle ourselves. If they give you the triangle, awesome. But with the problems that do not give you the triangle, default to how these are. All right, with that being said, let's look at the first. So a cat is walking along a street and sees a 10-foot lamppost. The cat looks up to the top of the lamppost at an angle of 58 degrees. How far away from the lamppost is the cat to the nearest foot? So, as you can see, the problem does not specifically state angle of elevation or depression, so we have to look for key phrases. Here, the key phrase is looks up. Well, if we go back to angle of elevation and depression, angle of elevation is looking up. So this is an angle of elevation problem. So we're going to draw our right triangle like this. And they tell us our angle is 58 degrees. So we're going to put it in the given angle spot. All right, so then we need to label. Right here is our cat. Meow. And then this is our lamppost. I don't know how lampposts really look, but there we go. So we know that the lamppost is 10 feet tall. And we want to know how far away is the cat from the lamppost. So we need to identify this length. So now that we have our pieces all placed, it's essentially what we did on the first page. We set up the trig function. So 10 is opposite, x is adjacent. So that means we're going to be using tangent. So tangent of 58 degrees is equal to opposite over adjacent. And now we just solve for x, rounded to the nearest foot. Variable is in the bottom, so we just flip-flop the trig with the variable. So x is equal to 10 divided by tangent 58. Let's grab the calculator. So 10 divided by tangent 58, and we get 6.2, but we want nearest foot, so 6 feet. There we go. So the cat is 6 feet away from the lamppost. So really, all the extra work you guys have to do with angle of elevation and depression is setting up your triangle. That's the only extra pieces that you have to do. All right. Jenna needs to climb down from a 14-foot roof. To safely use the ladder, it needs to be at an angle of depression of 40 degrees. So this one clearly, explicitly states angle of depression. So we're going to draw our angle of depression, which is 40 degrees. So this guy right here, so this is the house. Jenna is right up here. And it says she is 15 feet off the ground from a 14-foot roof. So as you can see, there's no side of the triangle here, but it's the same as this leg. So this is 14. And it says, what is the length of the ladder? The ladder is our diagonal piece. So now we have opposite, hypotenuse. So that is sine. So sine of 40 degrees is equal to 14 over x. We have the variable in the bottom. So we just flip-flop it. X is equal to 14 over sine of 40, and it says round to the nearest foot. So 14 divided by sine of 40, and we get 21.7. So we're going to round up to 22 feet. All right. Now, sometimes you guys will get the diagram already for you. That's the best because we don't have to draw our right triangle. So here we go. Last problem, an example for elevation and depression. So a fire truck has an 84-foot ladder leaning against a building forming a 55-degree angle with the top of the truck. So as you can see here, the hypotenuse is our 84 feet. We have 55 degrees as our given angle. The truck is 8 feet tall. So 8 feet right here from the ground to the start of, or the top of the truck. Because just imagine this is a fire truck. Woo! Ladder. So then, will they, the firefighters are trying to reach a window that is 75 feet above the ground. Will they be able to reach the window using the ladder set at this angle? So we need to find out if the ladder, the 84-foot ladder, will reach up the wall. So we need to see if this is the case. So we need to find out what the measure of the wall is, and to see if this is the correct degree measure. So we have opposite and hypotenuse. So we have sine of 55 is equal to x over 84. Variable in the top, so we just multiply sine 55 by 84. And we get 84 sine 55. 68.8, so we're going to round that up to 69 feet. So that's what we get for the wall. Again, they are 8 feet off the ground. So we need to now add the 8 feet and see, will this configuration hit the window? So 75, or not 75, 69 plus 8. It is 77 feet. So yes, they can reach the window. So it's okay if they went a little bit above. We would not want the length to be short. So yes, this will reach. And there you are, using trig to solve for the sides of a right triangle.